beginning and the end positions. That's what those brackets are telling you. So when we read this documentation, we get from it, it requires a substring. You can give it where to start. You can optionally also give it where to end. So optional, optional, not optional. No brackets for the first argument. We got to get that.
Evan, go back to your where you typed in the count command.
Yeah. That is not this is where I was typing it. My string got counted.
Okay.
Okay. So what I wanted to show is when we see that, we also see at the end this dash and then the greater angle bracket, right? Does anyone know what that is? Does anyone know what it looks like? That one's really
pointer.
easy. It doesn't look like a pointer. What does it look like?
An arrow.
There we go. It looks like an arrow, right? It's hard to look like a pointer.
I was going to say a logical yields operators.
That's really complex. I like arrow better. Yeah. Robert may be a little bit more precise than we need in this case. It looks like an arrow, right? And that's what you should see, right? It's pointing a specific direction. So you're giving it this crap. Two of those things can be optional. And what you're getting back out of it, right, where you're going with it, is you're going to get an integer. It's going to return the amount of things that you count. So I just wanted to be sure we can read this, right? Because this is the core of, I don't know how to do it and I want to learn. You're not going to memorize it all. This is how you do it. Start with help. Give it your variable name. It tells you your variable is part of a class string. You can go help, str, see the whole thing in the class. It tells you everything about it, what all Python can do. Right? You go, okay, I need count. You find it in the count tree. You can, from that point, you can read it right there. Or if you know that the method exists, you can go help string.count. All right, we got some questions. Ben.
The sub, bracket, comma, space, start. Are the spaces in there so that they don't get connected accidentally to the string? You're going to put sub. You're going to put something that starts.
The spaces are there to show you this, right? You have to have a comma if you have two arguments.
Okay.
Right? So how are you going to show a comma? They put the brackets with the space because the comma is optional.
No. That's not the part I'm asking about. I'm asking about the space. Could you, in some cases, I haven't needed spaces when I can type things.
When you say space, do you mean this guy right here?
That right there, yeah.
That's just there because if you have two arguments, you have to, well, they're showing you that, it doesn't actually require that, no.
That's
no.
what I was.
There's something called PEP 8, I think, which we talked about that before. That's the Python grammar Nazi document. They want that. But Python itself doesn't actually care if you have comments between your arguments. Okay. But by the way, the grammar, they take it, remember, they all take it seriously. They have unified behind it. Yes?
How do you find out what class variable is?
That's a good question. Anyone want to answer it? We went over it. Ed.
Type operation.
That's one great way to do it. That's one great way to do it. But if you have a question on a variable and you want to find out what class it's in, if you just feed it to help, it tells you. Right? So the type operation is how you do it in code. Exactly. That's what you want to know. That's your answer. But help will also gladly tell you when the object doesn't have help that the class may. Okay. Cool. So, def palindrome. That's the next question we have here. Dun dun. Right here. Yeah. Okay. It says exercise 8.3. A string slice can take a third index that specifies the step size. That is the number of spaces between successive characters. A step size of 2 means every other character. 3 means every third. You get the point. A step size of -1 goes through the word backwards. So the slice, -1, generates a reversed string. Use this idiom to write a one-line version of is palindrome from exercise 6.3. Okay, I'll make it, so this is what we're doing here. Use this to write the one-line palindrome. There we go. There's your one-line palindrome. That's all you need. You want to figure out if something is a palindrome, you're going to take a slice with no start and no end. Both of them are going to be backwards, but you're going to go in the opposite direction. -1 from the end to the beginning. Right? If you wanted to do every other one backwards, what would you do? Aha, not complex, you got it. Don't delay. -1 for this to determine the palindrome, -2 every other character, doesn't matter. Whatever you want to do. And what we're going to do is we're going to check to make sure that backwards it's the same as forward. That's what a palindrome is, right? It's a word that's backwards the same as forwards. That's what that does. So then where that is palindrome, a man, a plan, a canal, Panama. Remembered it from elementary school? Pat myself on the back. Yeah. Okay.
Yeah.
That's a palindrome for those that aren't as quick. But yeah, that's not just the test. Okay. Cool. Next.
So how do you know it actually worked then? If it's the same either way?
You give it something that's not the same either way, and if it doesn't return false, it doesn't work. Right? So I only showed successful working cases in this. Okay. So we go on, and it talks about this other problem that we have called rotate word. This is the Caesar cipher idea, right? So the basic idea is you give it a letter A. You want to shift it over 1, you get B. Shift it over 2, you get C. That's all there is to it. You give it a whole word. If the word has 5 A's, you're going to get back 5 B's if you want a Caesar cipher of 1, right? Because you're shifting it over 1. But you can shift over a word like hello too. So what we're going to do here is we take this one right here. PowerPoint fail. More complex than Python. Libre presentation. Okay. I'm going to copy this guy. Paste it right there. So here's what we have. Make it bigger. Construct, right? Because that's how you process a string. And that's a general Python idiom. You have a bunch of something, and you want to iterate over that bunch of something. You can use the in construct. We're going to see it in a minute. We have a file. What is a file? Python can think of a file as a bunch of lines. If you want to iterate over all of those lines, you can use the in construct. So we're going to see it. I just want you to start to piece all that stuff together. That's what in means. So for each I in word, that could also have said character, and it would have made more sense to everyone here. So for each character in word, what we're going to do is we're going to take the new word and we're going to add to it the character. So this book gave us 2 different functions as a hint. And let's take a look at that. It says, here's our hint. And this is like one of the tricks of the book is that when it introduces you the problem, it usually introduces you the problem without sufficient ability to actually solve it. So they just throw it in there, right? You might want to use the built-in function ORD, which converts a character to a numeric code, and
Is that like the ASCII code, or?
that's exactly what that is. That's exactly what that is. Character, which converts numeric codes to characters. Letters of the alphabet are encoded in alphabetical order. So for example, ORD C minus ORD A equals 2. Right? So ORD takes a character and it returns a letter code, the ASCII character code. We're not going to go into what that code means, but it's there and it means something. Now, for a question, let's say you want to know what word or character means. What do?
Help.
Character.
I love it. I love it. You got it. Okay.
Which one was the right answer?
Help. Right? Help car.
Help.
Returns a Unicode string of 1 character. Why is this giving me so many problems? Returns a Unicode string of 1 character with ordinal I. 0 is less than or equal to I, which is less than or equal to that, which is actually a hexadecimal number. Something we're also not going to go into right now. But the point is, you give car a character, and it returns to you an integer, right, between 0 and this thing, right? And the reason why that's not just something reasonable, how many letters are there in the alphabet?
127?
A lot.
No.
Oh, well, it depends on which alphabet.
Anyone else want to try that?
That was good.
Okay. Let me be a little more specific. How many characters are in the Latin alphabet? 26, right? So if there's 26 characters and we have lowercase and uppercase, right? There's 50 some odd characters, right? Ish, 60 characters, whatever. Ed?
Lower, upper?
I just said we're lower and upper. Okay. So we have 26 lowercase characters, 26 uppercase characters, right? The point here is we don't have that many to include all of the characters we Americans use. We have 50 something. To go into why that number is so much bigger than 50, right? Because this is substantially bigger than 50. We don't need to go into hexadecimal notation. It's just more than 50. The reason why that is because that includes all of the numbers for all of the character sets in the whole world and all of those annoying emojis your grandma sends you. Right? So all of that shit gets thrown in there, and every one of those has a specific number. Right? So now getting back to the point. If I give it car and I say A, damn it, ord A, right, I get 97. Right? If I say ord A plus 1, I get 98. Now, what do you think the character is for 98?
B.
Brilliant. Exactly, B. Right? Okay, so now we have an idea of how ord and card work together. And I'm only going through this because you're required to answer this question, and it wasn't in the book as far as I know. He just dropped it in there. You need to know this to answer the question. So we can go help car. We can see what car does. We can go help ord. We can see what ord does. These are all got-to-know things on Python. And now what we're going to do is we're going to wrap all this stuff together and create a rotate word thing. So what we do here is, make it big. Oop. Slideshow. Shift F5. I'm going to remember that. I swear. Okay, so what we're doing here is we're taking the ordinal, we're getting the ordinal number that the character represents, right, of I. So that's going to be for A, whatever, right? You remember what that was? For A, it was 97, right? Then what we're going to do is we're going to add to it the distance. If that distance is 1, what are we going to get? Ord A plus 1, we would get 98, right? We would get 98. Now what we want to do is we want to convert 98 to B. How do we do that? We throw it inside of this car. That's going to do the opposite. It's going to say, what is the character that this ordinal position represents? Right? So we give it 98. And then what we're going to do is each time we calculate a different character, that offset, right, we're going to add it to the new word. So we iterate through every character, and every time we say, give me the character, add the distance, give me the character that that represents, throw it on new word, move to the next character. We all got that? How are we doing it? Okay, so we rotate this thing hello, and there's the answer right there. Rotate word hello 3, chord. K-H-O-O-R. Now here's the thing about a Caesar cipher, and this is why people don't use them, and why I really find it hard to believe that anyone even then used them.
Oh, yeah.
Right? They're really stupid. You see a word that has 2 letters next to each other, O-O, and you'll see that that's the LL. Right? So it's not too hard to figure that out. You know, if you have Caesar's name and it looks Caesarish, but it's just off by 1 letter, the other general's got to be like, you're joking, right? Okay, but anyway, yeah, that's the childish games that the Caesar cipher is, and that's how it works, and that's how we implement it. So we have new shit. Okay.
Wow.
Yes.
Can you go back to the code?
What?
Can you go back to the code?
Can I go back to this code?
Yeah. So what happens when it's C? Is there,
We've written something that did wrap it around, but I don't want to do that with what we know so far. Okay. So yes, that's definitely a bug. So, moving on.
I know why I said 127 earlier. All the low order ASCII characters, 0 to 127, are all the one, include the alphabet, but it also includes like tabs and return. Anyway.
That's right, yeah. So when we have different ordinal characters, it's not just grandma's emojis that are in there, but it's also periods, exclamation points, commas, all of that kind of crap, So, and vertical tabs, which are tremendously useful. Okay, so now we have this thing called case study wordplay. This is actually good. This assignment is not bad. So I give the author a lot of crap in the past. This is not actually a bad assignment at all. So you'll be doing a lot of word processing when you do Python. It's actually more or less probably the most routine thing to do with computer programming.
Sorry, say that again. The word.
Word and document processing. That's right. using things like file IO. So when you have like someone sends you a file and you need to process it, you're going to be essentially using the same methods you're going to learn in this case study, right? So that's what I think is it's highly relevant. Okay, so we start off and we're introduced with this keyword open, right? So we essentially give this a file, right? Words.txt, and what that's going to return is what we think of as like a representation of the file. Right, so you give it a path. Let's be clear, that's a much better word. Step back and forget I called it a file. You're giving it a path for words.txt. You're giving it the location of the file, and it is returning to you an object that represents that file. Now we call that in computer programming a file handle, right? So when you want to access a file, you would call the thing you're using to access it a file handle. You would call the thing you're using to access a database handle. Which is your method of handling that data, and that Python or whatever you're using is going to abstract it. Fin is your file handle. Open is taking a path towards txt, returning the file handle. What does this do? Well, this is giving us the ability to call things like readline on it. Okay, so here's a question for you. Let's say you want to know what open does, right? How do you figure that out?
Help.
Beautiful. That's the instinctive reflexes you're going to need when you're doing computer programming. You want to know what open does, you call help. Help, open. Bada boom. And there's a whole lot of crap about help, right? About open. So we're taking this thing, file handle.readline, and what is it returning? It's returning one line. Now, you're going to see here that they have a /n at the end of it, right? That just means that there's a new line on it. So when you look at a file, it's just a stream of bytes. Right, that's the thing. The whole computer, it's all ones and zeros everywhere. Right? So when you look at a file, you have A, and then underneath A you have a B. Right? Well, to the computer there is no underneath. That's like a special thing that you do. Right? So how does a computer represent it? There's a character after A that's called the Newline Character. And that Newline Character tells whatever renders the text that the next character comes underneath it. That's how that works. So when you read from a text file, you call something like readline, the Newline Character is still on there. So when he shows you file handle.readline, that's what that n is at the end. Okay, let's go through the file and let me show you what it looks like. Vimwords.txt. There's actually the file. So we have AA at the top, but there's you can't see the Newline Character. Right? Now there is actually a method to show Newline characters in Vim. Someone figured out, it's not me, but yeah, it is kind of cool. But in Vim, the Newline character just gets rendered by putting the next character underneath it. So when you read it from Python,
You see the invisibles.
you see the invisibles. I like that. That's exactly right. You see the invisibles. Ed.
Set list.
Thanks. Okay. Set list.
Space.
There we go. Okay, that's not exactly right, but that's close. That's close. So set list is showing you that there's the $ to show you where the Newline characters are, right? So if you do, I think set list will also show you if you do like a tab. See how it shows you that's what the tab character looks like? Things render white. They call them white space characters because to a computer they're no different than the characters you see. They're no different than an A or a B. It's a white space character because whatever renders it, right, can do special things with it. And you often just hide it entirely. It's for formatting, right? So you see AA is the first line, but the computer itself doesn't. The computer sees AAN, and then right after it the next stuff. That's just the way you just gotta get used to it. Okay, so you call fin.readline on the first line, you get AA with a Newline character. You call fin.readline again, what do you get? You get the next character, AAH. The next line, AAH, with a new line, right? So here's what you take away from it. That fin, which I said was the file handle, every time you call readline, internally, it knows where it is in that file. And it's going to give you another line, and it's going to change its internal position. So you say, readline gives you a line, changes its position. When you call it again, gives you another line, changes its position. And that's how you work your way through a file, right? So there's this thing in here called line.strip, right? What is line.strip? Anyone want to take a guess at this?
Strips away the white space.
That's exactly right. But what is it strip on?
Whatever the parameter, whatever's fed in the
Let
parameter.
me ask you this question. What is line? Line is what's returned by fin.readline. What do you think a line is?
The string?
Boom. Brilliant. Brilliant. It's a string. So readline is returning a string. So let's go to Python here, and if we just show you something here, help string, I just want to pull it into full perspective. That's exactly what he's calling right there. Right? So the readline is returning a string, and the string can be stripped. So you have this thing called the file handle. The file handle has a method on it called readline. The method readline is returning to you a string object. The string object has a method called strip. You can call the method strip, and you get the string without the white space. Okay, so that's how this is. That's what's actually happening. Just so we pulled it all into.
Small clarification.
Yes.
White space on the ends.
Yes,
No.
that's exactly right. On the ends.
Oh.
In some other languages they call this trim, which I think makes actually more sense. But yes, it's white space on the ends.
Would you call that that Newline character a record delimiter, or you know you have a tab delimited text file, you have tabs between fields, and maybe a character return at the end, and some files.
Can I answer this one?
Go for it.
Yeah.
Depends very heavily on what you decide a record is.
Yeah.
Okay.
I think that's actually a good answer to it, but I would like to go. That's a terminology issue, right? It's just specifically what you want to call it. If you view the lines you're reading as records, then the new line could be a record separator. But that's not something we're going to do and handle just yet. So I think Ed's answer was actually pretty good on that. Okay, so word line.strip, right? But we can do it anything. We can even test it. Let's say we want to see what strip means. A equals hello. A.strip, nothing changes. A equals hello. A.strip, something changed.
Yep.
A equals hello. A.strip, something else changed. Removing the beginning and the end white space. And as Robert said, if there's space in the middle, it doesn't go anywhere. It's just trimming it. Okay. What I'm trying to do is I'm trying to show you it's not really that complex. It's just the string, right? So we take the string, we strip it. We looked at it then, and now we no longer have the white space on it. We can just see the word. That's what we're reading. That's what you want to see, right? You don't want to see the characters that you cannot otherwise see, generally speaking, when you do this. Or, as you said, the invisibles. And then this here, this is gold. You got to understand this. This is, again, when we were iterating over the characters in the string, I made a special point because I wanted to drive home how important the in operator is here, right? When you're iterating over a list of something, if it's a list of characters in a string or a list of lines in a file, in is the method you do it in Python. So you got to get that. And this is showing you here how to open a file and iterate over every line in that file. Okay, you get this, you get files. You're ready to move on to the next step. Okay, so solutions, exercises. Write a program that reads words.txt and prints only the words with more than 20 characters, not including white space. How do we do it? Well, we have this guy right here, and we know word is a string. So all we have to do is check to see whether or not word is 20 or more characters, right? That's it. You got to do something if it's more than 20 characters. We got to do something else if it's less than 20 characters. It's pretty damn simple. So what does that look like? Here we go. Words with more than 20 characters. This is my code, right? And I like to, when I'm doing this type of stuff, PyCharm is definitely the way to do it. Here's my rule of thumb on the Repple, right? And by the way, the eval loop thing, right? We've been using that term a lot. When I go into Python, just to recap it, and I'm doing this stuff, and I'm typing one line, getting an answer, typing another line, getting an answer, using help, getting an answer, doing all of that type of stuff, that is the REPL, right? So if you've heard of that term in the class and we haven't defined it yet, all that means is it's the read eval loop, right? It reads a line from you, you give it a line, it reads the line, it evaluates the line, and then it loops, waits for the next line. That's why we call it a REPL.
It's waiting for a line, you give it to it, it evaluates it, it waits for another one, right?
It actually stands for read, eval, print, and then go back to the loop.
I forgot the print, he's right. Read, eval, print, loop, right? And there's probably a whole page on Wikipedia about this, if you're really crazy. Yes, so, that's a very common word, right? And we probably used it a lot, and I just want to make sure everyone understands what it is. We had the question, when do we not use the REPL, right? Here's the thing, in most languages, using REPL is not a pain in the ass. In Python, it's a pain in the ass. Ed uses more than Python. Ed, why is the REPL in Python a pain in the ass? And I know he's thinking what I'm thinking.
Basically because Python scopes everything to the top level scope, and then on top of that, there's no way of saving any of the work that you did. It's gone as soon as you exit the REPL.
That's exactly right? So a lot of things have got these REPLs, these little read eval loop print things. We don't like them in the Python community, and I don't like using them for Python because if I type something that's multiple lines and I make a mistake, there is no up arrow changing it.
So the simple answer to that is to use Jupyter. You can go line by line by line by line. And
Yes.
you can go anywhere and correct it.
Use Jupyter, use a file, use an IDE. My advice is don't use the REPL
Use
for serious
anything except
development.
the REPL. I mean, Java has a REPL too, and it never went anywhere because basically it's the same thing. You have to type everything in whenever you need to use it. Tickle has a REPL. It's never used outside of learning contexts. REPLs are just very good for demonstrating something really fast. They're not actually good for programming long term.
That's exactly right on all fronts. I was going to show you a REPL that makes sense, but I don't have my database up and running. SQL has REPLs too, and when you're querying inside of SQL, you'll frequently use them to get like information about the database, and they're so much more commonly used that they're not nearly as annoying. They've kind of got the rough edges ironed out. But when you do stuff like this, def A, and then you come down here and it's saying, okay, it's waiting for the next line, and you say, okay, you want to print 1, and then you make a mistake, you can't go up arrow and redo it. You have to up arrow twice and redo everything, you know? For me, that's why I draw the line. So for me, the golden rule of the golden rule of the thumb or whatever is if you're writing something with more than one line in Python, you probably should not be using a REPL. You should be using something else. Golden rule of thumb? The rule of thumb? There we go. No gold? No gold?
As you do, yeah.
Not enough coffee nor sleep. Yes.
Yeah, I just want to add that you can do R strip or L strip if you want. Only your right strip or all that stuff.
That's a good point. Yeah, you can do R strip or right strip. And again, in other programming languages, they'll call it trim, but this doesn't make a difference. But the point here is that I moved all of my work to Python charm, so I don't have to go through the hell that is the Python REPL. So this is PyCharm. I've got it working on many of your computers. This is what we're using in this class. It makes things very simple. I have at the very top right my code, and it tells you everything about styles. We've went through some of this stuff. Here's the code right here. Remember, we're trying to find words that are longer than 20 characters, right? So let's see if this works. I'm not sure it's gonna. Yeah, that worked. Nice. Okay. So how do we find words that are longer than 20 characters? Well, by the way, this fin-seek thing, I can ignore this for now. What I'm doing here is, remember when I told you earlier we said read line, it keeps the place of where it's at in the file? Well, because I did all of this work in the same file, every time I do a different example, I have to say rewind, right? Because it gets to the end of the file. So seek 0 is telling it that little thing internally that knows where it's at in the file, forget where you're at and go back to the beginning, right? So it's not actually needed for the first one, but it is needed for the second one, right down here, which is my next example. So fin seek 0, we now know what that means, but it's not relevant to the example. This is the code here, right? 4-line in fin, right? This is the file handle. I want to say word equals line.strip. Get rid of that space on both sides. Then I want to say if the length of the word is less than or equal to 20 characters, continue. Skip it, because it's not what we need. We need characters that are greater than 20 characters. Yes, bigger is better, but this is stupid.
I can guide you through making it bigger.
That would be cool.
Go to the file menu.
File menu. Dude,
Go to settings,
dude,
editor,
dude, dude,
font.
dude. Oh, they made this a fucking trip. Okay. I don't know. 18? Sure. Okay, I hope that that's good. Let's take a look at it and see. Oh great, I can't hide the window either. Okay. Is that better? No. Okay, can we see this right here? Are we good? Okay. So what I'm doing here is I'm saying if the word is less than or equal to 20 characters, simply skip it. That's what continue does. Continue is one of those looping constructs we had. Continue means we're done with this iteration of the loop. Every time you're making a loop, that's one iteration, one time around. Skip this iteration, move on to the next one. Right? So that's all that we're doing. And then when I run it, here are words that have more than 20 characters. Counter demonstrations, beautiful. Hyper-aggressivenesses, and micro-miniaturizations. That's beautiful. Okay, so there you go.
Why'd you need continue then?
Because I want to skip that part of the loop, the for part. And what I want to do is, if it's not greater than 20 characters, I want to print out the word. So I want to stop it from printing out the word if the word isn't of that length.
So why don't you flip it to logic? Greater than 20 print.
Huh?
Why don't you flip the logic so if it's greater than 20, then print?
Yeah, you could do that too. That's
So
another.
both of these approaches
Are totally valid.
are
in Word.
functionally identical. So when we talked about that refactoring thing,
Yep.
one approach might be easier for a certain group of people to read than another, but they are both functionally equivalent.
Totally cool. In fact, I actually think that that's stylistically super superior. I literally did this while I was eating tacos at Taco Cabana. This is not serious code. So yeah, you got me twice now. That's 2 penny points for you. But yeah, he's right. You shouldn't have to continue there if you don't need it. You're just branching for nothing. So this is a lot better and cleaner. So if the length of the word is greater than 20, print the word. Otherwise, it's just going to continue to the next iteration. That works for this one. And we run it, and we get the same result. We get the same result because it does the same thing. Okay. And I think we can shift. No. How do I comment a block in PyCharm? Robert?
I use / in the Apple key. I don't know if you do it.
That's not helpful. Does anyone happen to know how to
Whatever your
comment
super key is.
in PyCharm?
Command / on the Mac.
God, you Apple users are killing me. Does anyone who's not an Apple user know how to comment stuff? It's what?
Flower, apple, and then the job
And then
key.
like comment,
If you do control.
That's awesome.
comment with my comment, that's what
He's
I do.
enjoying the pineapple pizza.
Okay, let's do hot or colder because I don't even comment. There we go. Comment with line. Okay, I see it.
Controllables for
You see the light?
Thank you. There we go. Okay,
So what's your command?
If you highlight it, put control /
that's it. That's what I was looking for. Yeah. Okay. So we have the next one. So the next one in our example is find letters that don't have E, because this guy in 1939 wrote someone a 50,000 word novel that didn't have the letter E, which is brilliant. Okay, way too much time on his hands. It's like the annoyance of Twitter times a billion, right? Okay, so let's take a look at what he's got. What we have got here is for line in fin for every. It's the same. That's the idiom. That's how we do this. We okay. Word equals line dot strip. We know that. Word dot find E. Right now, here's the thing. Not equal to 1. What is that? Okay. Well, if you want to look for a letter E, right, but you want to know when the letter doesn't exist, what do? Okay. So we go help str.find. And what do we see? What does this say? Anyone wants to read that?
Not a failure, is a pass.
return -1 on failure. Python, if you call find on something that doesn't exist, right? You say find E in the string that doesn't have any E's. You know, find the needle in the haystack that has no needles. Whatever it is, you're looking for something that doesn't exist. Python considers that a failure for the purposes of documentation, which is weird, but that's what it is. So it returns -1. So if I'm looking for an E, the string doesn't have it, I want it to return -1. So what we're going to do here is I'm going to say if word.find E is not equal to -1, then continue. Otherwise print word. Now what I could also do is I could do this, right? Per the last advice. Print word. Okay. And let's run this and then exit 0.
We touched that before.
Indentation is not a... Jesus, they really like this style stuff. Okay. Boom. There we go. So if you were going to write a 50,000 word novel, right, that didn't have the letter E, this program would probably be of assistance because it would tell you words that you could use. Okay? And good zucchinis. Fascinating.
Well, you could use your zucchinis with the Zymer chip,
There we go.
but you can't make beer.
Zecoritus. Zekorits. Is that like the Egyptian thing?
It's like a ziggurat.
Ziggurat?
I have no idea what that is, but I know it's Zymer chip.
The Mayan thing?
Yeah.
Did I get that right? Ha yeah. Okay. Jeopardy, here I come. So yeah, this is how we do this one. Okay, so moving on. Now we're going to hold control. We're talking about, you guys want to know PyCharm stuff. I asked the question, got the answer. Hold control, hit the one character, comments out the whole block, and we move on.
You got the wrong continent, but the right idea. Mesopotamia.
Yeah, I was going to say. It's not mine.
Who said Mayan? I didn't say that.
I recorded.
It's from Babylonia.
Someone said Mayan, and I'm taking only half the blame on that one. I didn't actually say Mayan. Okay. Yeah, so anyway, we control about this one and chat some more later. So we have this thing, now what we're doing is we're moving on. And we're moving on, I swear. There's exercise 9.3. Write a function named avoids that takes a word in a string of forbidden letters and returns true if the word doesn't use any of the forbidden letters. Right? So this is an abstracted version of the last one. The last one said we couldn't use E. This one, it's going to take a list of letters and say you can't use any of them. So if you want to be even more of a jerk, you could have given the guy his book back and said, look, you didn't use E, but I also have a problem with the letter B. And then you could run the same type of test and make sure that all of those words have neither of those two letters, B nor E. Right? Or you could one-up the guy and write a whole book that has neither of the two letters and have your own Wikipedia page. So how do we do that? Well, here's how we do it. We use word.find, and then I give it the letters, and then I say not equal to 1. So rather than just E, actually, hold on, maybe I did this wrong. Write a function named avoids that takes a word and a string of forbidden letters and returns true if the word doesn't use any of the forbidden. I did that wrong. So I actually wrote the code that only forbids one letter, and it should actually forbid multiple letters. Okay. Nonetheless, how would we modify that? Do I want to even live code that or just skip it?
Code.
Live code? Live code? Are we live coding? Okay, so let's think about it. If we want to take letters rather than just simply one letter, right? We want to take multiple different letters. Well, first thing, let me see how find works. Let's see here. This is how we do it. We're going to test it, right? Let A equal, not JavaScript, A equals foobar, right? That's our basic variable here. Now I want to say A.find And then let's see C. That doesn't exist. We get -1. I know that. Now if I say CB, that equals -1. So it is doing what I expect it to do. Okay. So what we want to do is we want to say word.find. Okay, so here's what we would do. We would say here, if I in letters
Have a recommendation?
what's up?
Well, I was going to recommend that from like a pragmatic approach, you can assume that the number of band letters is going to be shorter than your word, because that's the general case. So I would recommend looping on the band letters rather than word.
Is that'll work though, right? Did I just live code that right?
Yeah, I think
Okay.
the Pythonic way to do it would be to if letter in word. If I'm not mistaken, but that works.
Yeah, okay. Regardless, this works. So,
It's like it works.
well,
You've got some parentheses in your for that makes it weird.
okay. Avoid foobar, and then AC, and now I want that to return if word.find letter equals 1.
Again, can I make a recommendation?
Yes.
So I would try replacing that if statement with if letter in word.
If letter,
In word. Yes. Remember we covered that int actually does a search.
yeah. If letter in word,
Yeah, that's the Pythonic way it's supposed
Okay.
to be like readable.
so return false. If the letter is in the word, we're returning false. Otherwise, we're returning true. All right, let's give that a shot. And that's not working. So where's the mistake in that? For letter in letters, that we're going to iterate over each one of the letters that we're given, and for each different letter that we're given, we're going to say if the letter is in the word, right, these are forbidden letters, then we're going to return false, because we haven't passed this test. Otherwise, we're going to return true. Avoid foobar. Now this I would expect to return true. ZK true, ZO false. Okay, that is working. I don't know why it wasn't working before. Maybe I did something stupid or it wasn't reloading. Okay, so now we have it, right? Does everyone see how this works, what we're doing here? Now that we've live coded this with all of the bugs of live coding. So the original avoid that I wrote only looked for one letter. This new avoid that we wrote, we can give it a whole entire string of letters, right? And what we're going to do is make sure none of those letters exist in the string. So when I say here avoid foobar and I give it ZO, it's going to make sure neither Z nor O appear in the string. Because O appears in the string, it's going to return false. If I give it two letters that do not appear in the string, like Z and X, I'm going to get true, right? So the one that I wrote, if you remember, we wrote this one just above it that's looking for E. I could also have written it like this, right? And then I would just have to give it the E. So we could write this function here was called, well, it wasn't even a function, so we'd have to make that one into a function. But you could say, provide avoid the word and E, and it'll make sure E doesn't exist in that word. Okay. So the next one that we have here is uses only. And here you give it word and allowed letters. And what we're doing here is we're saying this is actually the in method that we were doing just a second ago. Uses only, you give it the word and the allowed letters you can use. And if any of the letters aren't in the allowed letters, then what we want to do is return false. So now you can say what letters you want the word to be made out. So if I come over here and I say, let's copy this, uses only, and we'll show you how it works. And I say uses only, foobar. Now what letters do I have to make this work? I have to have an F, an O, a BAR, right? And I get true. If I put a Z inside of foobar, like that, I get false. Because the Z is not in the list of allowed letters, right? So again, for I in allowed letters, looks at all the allowed letters we have, and it says, if any of those are not in the word, we want the whole thing to return false. Otherwise, we want it to return true. And there was my little test case on this. And then we introduce another one. And by the way, all of these will work on the file we just gave. So we're giving it word processing functions, and you can call these word processing functions over the whole file. So we're going to see that in a second with this guy. Let's comment these out. And it's control / they're all gone. Now we have this thing called Abecedarian, right? And an Abecedarian is a word in which all of the letters in the word come after the letter that they precede. So if you give it A, B, C, it passes. If you give it A, B, C, A, it fails. How many words can you make like that? Right? Well, the author gives his formula too. Mine is slightly different, and I'll tell you both why. Here's what I've done. I say we start off with previous letter, and I assign it a -1. Right? Why do I give it a -1? Because every letter we go through, the ordinal values of those letters are all greater than 0. So I start off and I say, give it -1, so I know whatever letter I get is going to be greater than that. I know I'm going to satisfy that condition. Then I say for I in word, if the ordinal value of that character I is less than the previous letter, return false. Otherwise, I want to set the previous letter to ordinal I and continue the loop. Right? And then every time we loop through it, we're checking the ordinal value of our current letter against the ordinal value of our previous letter. Okay. Now, the author did it almost the same way. The only difference in the way the author did it is he simply left word off entirely. And the reason why he was able to do that is because in Python, you can compare letters. A is less than B. So for those of you that did the book and you went through it, let's hit this up. Abecedarian has no E. Here he does his. By the way, I did all of my work, and then I saw that the author actually does all of his there. He does his work like this. Previous equals word 0, right? So he's looking at the first character is what he sets his to. And he says, make sure that the next character that we have as we iterate is not less than the previous character, right? So he doesn't use the OR thing. That's the only difference. Okay, but nonetheless, the word thing works totally fine, and the point is there's more than one way to do it, and his way is slightly better, and it's definitely more Python-y, but we'll use my way first. Abecedarian, ABC, true. ABCA, false. Okay. So if we wanted to find out all of the Abecedarian words, how do we do it? This is where he brings it all back together. So we've created a bunch of functions today. And all of these functions look at words and they return true or false. Right? Is the word an anagram? Does the word not have an E? Does the word not have any forbidden letters? Does the word only consist of these letters? These are all the functions that we've created. And the return value of all of those functions is what?
True or false?
True or false. They all return true or false. Boolean. So this is what he does here to bring it all together, to show you what we're doing. Let's see here. We have created this, and we say print Abecedarian words. I seek to 0. We already went through that. I say if uses Abecedarian word. That's going to return a Boolean, right? Come back here. You can see when I said uses Abecedarian, ABC, true. Uses Abecedarian, false. Right? You see this? That's showing you the return values. We have it in a conditional. If uses Abecedarian word, it's the same thing as saying if true. After that gets evaluated. If true, print 1. Right? That's going to print 1. If false, print 0. And what I want you to see here is that's all that happens. This evaluation of if Abecedarian word essentially just amounts to one of these, if true or if false. The return value gets substituted there. So if this is true, we print the word. Otherwise, we skip it and move on to the next iteration. That's all there is to it. And then here's the results down here, because that's how, again, PyCharm is showing it. So you can see it. And what's the very last one? Anyone want to read this word that's highlighted? Tux, right?
The wheel hint. There's a button there that says Python console. Right under the yes.
What are you trying to show me?
Well, you don't have to switch back and forth between terminals.
Ah, okay. That's cool. That's a cool point. Cool deal. Yes, good idea. So we're talking about PyCharm hints, right? We had a couple of people that were legitimately asking for this. This is another one. Robert is the apparently the god of PyCharm here. So we have here Python console. You can hit this button at the bottom and you can type Python code right into the REPL inside of your IDE. So you don't have to do this. You can just do this thing down here, right? And you can say print 1, and you can get the result. And then you can go back to your run thing and continue. Or you could go to terminal and probably type in, all kinds of stuff. Okay, cool hint. So here we are, we have Tux, right? So how is Tux Abecedarian? Does T come before U? Does U come before X?
Yes.
And Tux is, by the way, the motto of Linux, so that's a good way to throw that in there too. That's this guy right here, Tux the Penguin. Okay, so Tux is Abecedarian, and that's all there is to say about this. All right, so before we go on, I think it's necessary to ask the question, Ed, is there going to be pizza today?
As far as I'm aware, yes.
Okay, so we can plan accordingly.
It seems to be dragging, though. It's usually the
Oh, the rain.
Yeah. All right, well, we're going to keep hitting it. Okay, we had finished all of the examples in this
Earlier in the meeting, the class, you did a lot. So the big use for Python is working with words or doing quote word processing. What you say, it's really well built for that? It's often used for that, or I just
No. It's not especially well built for it. The thing is, here's the deal. When you're doing computer programming, unless you're talking to yourself, you're going to be communicating with something else, right? And what I mean is like this REPL stuff. We're literally just, there we go, the man of the hour. Okay, he needs a cape.
Yeah.
What if you're communicating with anyone, right? You have two methods to do it. One of them is binary. You're literally twiddling bits and zeros, right, in a binary format. The other one is text. So a lot of formats are transferred in text. They come in as JSON, which is text.
okay.
In all of these formats that come in as text, knowing this basic idiom, for line in file handle, is highly relevant, and it's something you're going to be doing all the time, because it's how you're going to communicate with everything. And here's one of the cool things about Linux, right? We know we have a lot of people here that aren't using Linux, right? In Linux, everything is exposed to you as text. If I ask you on a Windows machine, how do you figure out what type of processor is in your computer? Does anyone know how to do it? You
Right-click on
okay? We have a right click. We have a what?
That's the same thing.
Okay, we have right clickers, right? Well, right clickers are not very well suited to the Python administration world because Python doesn't have right clicking built in, and when you're writing a program, you don't have it right click on my computer, right? So when you're on Linux, this is one of the differences. This is why I think that jumping into the platform and getting immersed will make you develop faster. In Linux, we have this thing called proc. This is just a total side note, but it's really cool. And we have this thing, CPU info, and this is just a file. And it tells you all this stuff here about your CPU. There's my CPU right there, right? All of this stuff is exposed to you as pure files. And that's one of the themes of Linux. So to Dan's question, this 4-line and file thing, you can use this everywhere. You can use this to find out what CPUs you're using. I can use this to read whether or not my little light is on my computer, or whether or not your computer's battery is about to die. You want to write a program that tests to see whether or not your battery's dead and drops you a notification? How are you going to do that in Windows? In Linux, it's very simple because the battery indicator tells you how much battery you have, and it's in sys. So you can come down here, and you have all of this stuff. This just is power, And I'm just saying locate all of my files pertaining to power. Everything in Linux, all of you have an interface directly into the kernel, and it's just text. Anyway, that makes me excited. Yes?
I think you can use sysinternals for Windows.
They're like a pseudo layer that talks to the Windows kernel?
Yeah, it's a guy that's on Microsoft. The guys in charge of Azure created it.
There are tricks on Linux to make it behave more like Windows. There are tricks on Windows to make it behave more like Linux. And there's definitely kits that help you to do this. My favorite is the Linux for Windows subsystem or whatever they call that, because then it just works same to me like everything else. But yeah, they have their own methods of doing it too. The point that I would make here is that it's in your face on Linux. It comes off the shelf. Everyone knows it. Every system administrator knows how they work. And it's just there for you. And I'm only bringing this up because the question is, what can you do with processing a file? The answer in Linux, everything.
Text really rules the world, but no one really knows it because they're in the average users in the GUI so much. But I think that's kind of your point, is that behind the scenes and under the hood.
Yeah. HTML is the text transfer layer. JSON is text transfer layer. All of this stuff is text transfer. If you can modify text and parse it, you can get through it. Okay, cool. We had pizza. I think we're almost done with this chapter, if not entirely done with it. Yes, we have indexes, and then we're literally going over the next thing, which is perfect. Okay, and that is this part here called looping with indices. Right? So what we do here is we are essentially finding out that previously, when we iterated through a list, right, we used in. And remember what in does? Who here thinks they can summarize what in did? We've seen it now in strings, right? And we also saw it with files. Ed?
Is it being used in the context of a for loop or an if statement?
A for loop.
A for loop. Then it iterates over the elements in the variable.
Okay, it iterates over the elements in the variable, right? So what is it? If we give it, let's say that we have a string and it has 5 characters, A, B, C, D, E. And I say for character in that string, right? What do we expect to get? A, B, C, D, E, right? But here's the thing. That A, B, C, D, E, those characters, they have no positional information to them, right? You don't know whether or not the A is at the beginning or the end. You don't know what comes before or after. All you're doing is you're getting elements when you iterate with an in loop, right? When you iterate with in. So the thing here is that that's not always what you want, because sometimes the location inside of that matters. Sometimes it's significant. So when it's significant, when the location matters, you can loop with indices. And in this method, you're actually indexing into those containers. So how do you do that? Now you don't get the element back, the A, B, C. Now you get back whether or not you're on the first element, the second element, the third element, right? So when you get this kind of information back, you got to go back and you got to say, hey string, I need your third element. Hey string, I need your fourth element. And in Python, you do that with brackets, right? You can do it with brackets on strings. You can do it with brackets on lists, which we're going to see here in a bit. But in Python, when you want to index yourself into something with a lot of elements, you use brackets, right? So if you see brackets, what you need to think is, generally speaking, right? Not always, but generally speaking, you're going to get one of something back in a list that will have multiples of something. Now we're going to see some violations to that too, right? But this is a good way to think about it. If you see something like this here, right? Let's take a look at it. We have this thing we're calling Abecedarian. We've already specified what that is. Every letter in the word, right, comes after the letter that preceded it, right? We say here previous equals word 0, right? Word is a collection of letters. That's how Python thinks about it. It's modeled strings as collections of characters. And we can say here that we want to start off with the first character by saying previous equals word 0. Now that's not, in that case it's the first, right? Because all things, generally speaking, unless you're evil, with computers, all counting starts off with 0, right? And there's a lot of really, really good sane reasons for it, which we're not going to get into. But you just got to remember that if you want 10 of something, you're going to get 0 to 9. The last element isn't 10, it's 9. That's because you started off with 0. So the first element is 0. So when we say previous word equals 0, we're saying out of all of these characters, I want to get the first one. That's all there is to it. For C in Word, for every character in Word, if C is less than previous, return false. Otherwise, set previous equal to the character and return true. This is almost the same loop that I wrote. The only difference is it doesn't use ORD, right? And does anyone remember why me using ORD was stupid? Dan, you had an aha moment when I showed you.
But like using the word, I guess it wasn't descriptive, or didn't, I'm not sure.
Why did I wrote with ORD what this author does not, right? He's not using ORD in this. He's actually... This is the key right here. C is less than previous.
Right.
Because Python has the built-in ability to, like, you know, is A equal to B, to do operations on a character like that, like he's doing, like C less than
That's
previous.
exactly right. That's exactly right.
I was talking about ASCII, I guess.
Right.
You know, so this was, like that.
So here's the deal. Here's the deal. When you look at characters, for the purposes of English, it doesn't make any sense outside of teaching the ABCs, whether or not B comes after A or before A. Unless you're alphabetizing things or you're teaching the ABC song. They're all just characters. They're discrete. And sometimes the ordering of those characters actually changes, which is a real blast. But the point here is that Python has a built-in ordering for the ABCs. It knows alphabetical order. And it knows that because they're all encoded with different little numbers. So you can actually say, is A less than B? And Python will say, yeah, it's less than B. Right? You can say, is, J less than Z or whatever. Python has the ability to do that. So when this is the key here. If the character that we get is less than the previous. Okay, an alternative version of this, right, looks like this. Now we're seeing something different here. Here we're saying length of the word, right? So word is a collection of characters, and length is going to return to you how many characters there are, right? So if I give it something like this, let's come down here and let's play, because this is really a great way to learn, and playing is easy. If I say A equals foo, and I say length A, what am I going to get back?
3.
3? Anyone want to say 2? 3. Nice, right? There are 3 characters in there. This is the reason why I like playing, right? There are 3 characters, but the last character is indexed as the second element, right? And this is the way a lot of things work, right? So length is going to tell you how many characters there are, not what the last element is.
Or the index of the last element.
Not what the index of the last element is. That's exactly right, right? And if you get confused at that, go play. Just open up your REPL and do what I just did, right? Because that's how you're gonna learn these things. And it's look how easy that is. So there's nothing wrong with forgetting it. Just go back and relearn it. Teach yourself by messing around. Okay, so here's another question. If I say A equals an empty string, and I say length of A, what am I going to get back?
0.
1.
0.
0. There's nothing in it. There's no length. It's empty.
What if there was a space?
Huh?
What if there was a space?
1. Ah. Good question.
1.
Yeah.
Because of Newline.
It's so all of these things you can't see, Python counts, right?
Good counter.
Yeah.
What if the string was \0?
And that's actually a tricky one. I don't know the answer to that one. Thank
He wants to break it.
Thank you for bringing that up in this class. I appreciate that.
He wants
Length
to
is
break
1.
it.
There you go. Okay, so that's a special thing, but we're not going into that right now. Okay. Yes, instigator. We do appreciate that every now and then. It just comes at other people's expenses sometime. So here's the deal. We want to go back to this, and we want to take a look at what the text is actually saying here. Hold on.
You're doing live?
Yeah. Okay. Okay. So what we have here is this where I was? No, I'm not on this. Okay, I'm here. If the length of the word is less than or equal to 1, return true. Right? Why are we doing that? Anyone want to take a guess? If I say, is the word Abecedarian, and it's AB, we know it's true, because B comes after A. If I say, is the word Abecedarian, and there's one letter, and that letter is C, is it an Abecedarian?
No.
Yes.
Nothing follows the first letter, though.
Nothing follows the first letter, is it? It doesn't matter, right? In this case, it is. That's what that is. That's what that's for. It doesn't make sense to test if something is Abecedarian if there's one letter. It either is or it isn't, so make your decision and then, bake it into the code. And that's what we did. Okay, if word 0 is greater than word 1, what do? We return false, right? Why? Because if word 0 is greater than word 1, then the letter is bigger than the one that comes after it. It's not Abecedarian.
Right.
It would be Ebadarian or whatever, Ba-Darian. Otherwise, what we do is we say return is Abecedarian, and then we look at every character after the first one. That's recursion. We talked about that before. Okay. Now, when we went over recursion, did I teach recursion or did Ed? I taught recursion? Okay. If I taught recursion, I always, because I've done this a lot, I know what I do. I always say when you're doing recursion, you have to always think about one thing, right? What's that one thing?
Stack.
Not really, no.
The terminal.
Boom.
Yeah.
Boom. This guy's got the word. The terminal condition.
Yeah,
When does it stop?
Okay.
Right? What are you doing to approach the end of that? Right? Well, here what we're doing is every time we call Abecedarian, we're saying take the word that I got and create a word with the second character and everything after it. Right? So if you say Abecedarian ABC, it checks out. A comes before B. Then it calls Abecedarian with BC. And then that checks out. And then it calls Abecedarian and it says, now I only have C. Is C true or false? C is true. Why is it true? Because we defined it to be true. We said if we only have one character, true. So you say, in the recursive case, every time you approach a string with a length of 1, that's your terminal condition. That's what you think about. So you can write a recursive Abecedarian function, ABC, then you get A is done, BC, then you get C, C is true, they're all true, you're good. And if any of them are not true, it returns false, and it stops recursion. Okay, so that's how we think about that. Another way is to use this while loop. And again, what we're doing in each one of these, right? These are all using this method of indexing into the word, right? Here we say here, while I is less than the length of the word minus 1, if word I plus 1 is less than word I, return false. Otherwise, what we want to do is say I equals I plus 1. Right? So what we're doing here is we're starting off with an index of 0, and then we're saying while I is less than the total length of the word. Now remember, we had this little catching case that we had. We started off, and I said, what is the length of foo? We got 3, right? And then we said, what is the last element of foo? What's the index? 2. What are we doing here? Length of the word minus 1.
Because you want to use it as an index. So you have
Aha, because we want the range to be the index into those words, right? We want the range to be all of the characters in the word. So we start off with the 0 character, and we end with the length minus 1. That's the key. That's the idiom. And this is everywhere. So when you see length minus 1, you know it's being used as an index. Right? Mm-hmm. So that's why we're doing it, and that's what that's for. And if that confuses you, go play. It's a great way to learn it again.
Always.
So we have this, we return false, right? Otherwise, we simply increase the index, and we keep doing that until we're on the last character. Does that make sense, everyone? Does anyone have any questions on that? Okay, cool. And that's all there is to it. We're done with strings. There's nothing more to this. Boring stuff about debugging, which has no code in there, has vague statements, testing problems is hard. Yeah, great. And then, bada boom, done. Okay, there are 3 exercises on here. I'm going to go through the first 2, because why not? And then I'm going to leave off the third one. You guys can play with it. If you have any questions, drop them off in chat. Great thing about these exercises is that he gives you all the answers to them, and they're workable.
That's good.
Yeah, it's actually really good, because I'm not going to actually write this code. So he has this thing called car talk, content puzzlers, and what he's saying here is he wants to find out a word with 3 consecutive double letters. What is that? A, B, B, C, C, something like that. But it doesn't have to be that. It just has to have consecutive double letters. B, B, A, A, C, C is fine, any variation of that. They're all double letters, 3 of them next to each other. I actually thought this was kind of a cool piece of trivia. So I like this problem. This is a good problem. Author gets a pat on the back. So he says, find me some shit that's got 3 double letters. And we have this whole list of words, right? How are we going to do this? Okay. So we're going to look at his solution. And we're going to work through it. Okay. So he creates a function. Is triple double word. Oh my God. That reminds me of the first day. We're all scarred after that. Is double double, right? Double double. Okay, now we have triple double. Thanks. So here's what we're doing for triple double. We have we're doing the same thing we did before. We see this idiom, length of word minus 1. We're looking into the indexes of the characters inside of this bucket of characters, which we call a word, right? That's how Python models strings. So we say here, if the word I, that character, equals the character after it. This you cannot do with iteration, right? You can't do this if you say 4 character in string and you get A, B, C. Because how are you going to say the character after B if you get that? You can't. You can only continue to the next loop. This is where this comes in handy. This is why this is a great example. So we're saying now we're looking at word I and we're looking at the word, the character represented by this index, and then the character that comes after it. If they're the same, we increase count. If count equals 3, we return true. We have a triple double word. And if the count is not 2, is not 3, then what we do is we say I equals I plus 2. What are we doing here? Anyone want to take a crack at that? What does that line do?
It skips to the letter after that double, or to the index.
It's moving the index
double.
up by 2, like he's saying.
Beautiful. And it's doing that because we're looking for doubles. And if we found a double, we can't go to the next character, right? Because that doesn't make any sense. So we need to jump 2 characters over. right? So if we have A, B, B, C, C, we hit A, we say A is the same as the character after it, right? We're on index 0. Now where do we go? We want the next iteration to not be index 1, because we know index 1 is the same as index 0. We've already satisfied the first double condition. We need to look 2 spaces after it. So we go index equals index plus 2. Now we're not going to the second A, we're going to the third character, which is a B. That makes sense? You all got that? Okay, now here's a good question, because we have, blue shirt. Name? Mark. Mark's good with the edge cases, and I know he's already got one. What are we missing here, Mark?
Short words?
Okay, right, what do we do if we have AAA, BB, CC? Aye, now what do you do? Okay, so it's not perfect, right? But the point here isn't to find edge cases with stupid, silly examples. The point is to kind of teach indexes, right? If you have AAA, BB, CC, you have a double, triple word. The first character doesn't matter. The second character, A, is the same as the third character. The fourth character is B, the fifth character is B, the sixth character is C, the seventh character is C. You just don't catch it, because you start off at the beginning, right? So this only catches things that are that kick off with the double triple, right? You can't start off with the triple and then go to doubles. Anyway, if that didn't make sense to you, it's perfectly fine. It's not incredibly important, but it is definitely a case you didn't catch. So so what we're doing is we're jumping to on the index, and then that's all there is to it, right? So then we have this thing here, find double triple, and essentially what find double triple does is it's going to iterate through all of these characters. Again, we create the file handle object by giving it the path, words.txt, being meticulous about that verbiage there. And then what we're doing is, as we iterate over every line in that file handle, we're simply running it again. Remember, is double triple is returning a what? We had it earlier. Is double triple returns either
True or false.
And that is a
Boolean.
Perfect. So we have a Boolean condition here that's telling us whether or not this word satisfies it. If it does satisfy it, we print it. Okay, so here's something else I wanted to show. He has given us this code. He makes it all available on a GitHub repository. Right? So here it all is, and essentially he puts this stuff under car talk. So if I go vim, I should probably open this up in PyCharm, but I'm not. A little bit of diversity will kill. This is the file here. This is the same thing you just saw. This is from his repository, right? And you'll notice here in his repository is also a copy of words.txt. So you're ready to rock if you want to download his code and play with it. You can find it on GitHub. You can pull it into PyCharm. You can do whatever you want. Python 3, car talk 1, and where's our words? What are they? What's the word? Bookkeeper. Bookkeeper is your double triple. Triple double. Whatever. Bookkeeper is the one that satisfies it. Why does it satisfy it? BOOOKKEE. There's your triple double. So if you're on Who Wants to Be a Millionaire and you get asked that stupid absurd question, bookkeeper is the only word in that word list that satisfies it. And how many words are there in that word list? For those of you that don't use Linux, we have a utility that tells us that on Linux. I'm not actually a hard sell, I just like having fun. So here we have 113,000 words in this file, and the only one that satisfies this double triple is bookkeeper. Anyway, yeah, cool stuff. So he has one more.
Can you do that in Python?
Yes, we could. We could do it in Python very easily. And hopefully for those that don't use Linux, that do know Python, you can write Linux utilities in Python. That would be pretty cool. There's a basic. Okay, so write a program to find a solution. Here's another one. I was driving on the highway the other day, and I happened to notice my odometer. Like most odometers, it shows 6 digits in whole miles only. So if my car had 300,000 miles, for example, I'd see 300,000. Now what I saw that day was very interesting. I noticed that the 4 digits were palindromic. I hope that's not a word. That is, they read the same from forward as backwards. For example, 5445 is a palindrome, so my odometer could have read 315445. 1 mile later, the last 5 numbers were palindromic. For example, it could have read 365456. 1 mile after that, the middle 4 of the 6 numbers were palindromic. And are you ready for this? 1 mile later, all 6 were palindromic. The question is, what was the odometer when I first looked? My question is, did you actually notice that, or did you write something to figure this out? That seems like a pretty sick perversion if you're actually noticing that shit while you're driving. You're more distracted than me watching YouTube. So how do we write code that does this? Let's take a look. And I guess that there's a whole series of these puzzles that this author's tapping into.
It's a radio show.
A radio show.
Carroll.
Very cool.
Well, you
It
see
was,
the radio show.
it was
Tappet Brothers.
it was a great show, but it's gone now.
But how does it relate to this, the car talk show?
Because that's where they get the puzzles from.
puzzlers. That's
where
where
these
this
are
came
puzzles
from.
come
Oh, I see.
And it was all car related, so odometers probably play in.
Yeah.
Probably one of their puzzlers that
They really work hard.
Yeah, I wouldn't be surprised if both those were.
This would be an incredibly complex puzzle to solve without a computer program. In fact, that I would actually like to see Ed teach me, because I am much more math stupid than he is. But I have no idea how you would write this palindrome stuff like that. So here's what we have. Def is triple double word. What we're doing is we're guessing, right? That's essentially it. You don't have to be smart, because computers just burn energy. So eventually they'll figure out the right answer, and you just hope you live long enough. So what we're doing here is we iterate through a bunch of numbers, and we simply say, does this one fit this criteria? And if it does, we're golden. So we have I equals 0, count equals 0. While I is less than the length of the word minus 1. Again, we're going through every different character inside of that odometer reading. We're saying, does this character, equal the next character? Wait a second, this isn't the right piece of code. cartalk2.py, there we go. This is the right piece of code. Okay, we create this thing as palindrome. I'm sorry, I was off. So here, the palindrome is essentially taking, what are we doing here, right? We take an I, a start, and a length, and we say, checks if the string representation of I has a palindrome. I is an integer, start where in the string to start, length of the palindrome to check for, right? So we look here, and we see that we're getting an integer, and we're converting it to a string. The reason why we're converting it to a string is so we can make sense with the equal sign, right? So we convert it to a string, and then we can use this slicing operation, right, to say that we only want from the beginning until the end that we're giving it with this length. So if we say start at 043, we get the first 3 characters, right? And then what we're doing is we're returning that slice, right? We're returning a Boolean that represents whether or not that slice is equal to the original piece. Okay, so this is the basic palindrome checking thing that we have written before. The only difference to this is that in this palindrome checker, we give it a starting position and a length. That's it. So what we're doing now is we're checking to see if I has the desired property. What are the desired properties? So this whole riddle boils down to different starting positions and different lengths. Did anyone notice that? Okay, let's go back to the riddle, and I want to just cap it so we can all follow how we're doing this. Because we have these questions, where do we start? Well, here's what you start. You start with this observation. I was driving the other day, and it happened to notice my odometer. Like most odometers, it shows 6 digits, right? So you only have 6 digits to deal with, first piece of data, right? This isn't 7 digits, you don't have to worry about it. In whole miles only. So if my car had 300,000 miles, for example, this is 6 digits. Now what I saw the other day was interesting. I noticed that the last 4 digits are palindromic. So you skip the first 2, you move to the last 4. Skip 2, check out the last 4. Is it a palindrome? That is, they read the same thing forwards backwards. For example, 5445 is a palindrome. So okay, we already did that. 1 mile later, the last 5 numbers were palindromic. Skip 1, check the last 5. For example, it could have read, whatever, 1 mile after that, the middle 4 of the 6 numbers were palindromic, right? What does that mean? The middle 4 numbers are palindromic. You have 6.
Look at the next 4.
The zero.
Precisely. 100% right, can't improve it. Skip 1, look at the next 4, leave off the last one. Beautiful. Well done. Okay, 1 mile later, all 6 were palindromic. So all of these take a string, and then we're just looking at different lengths, starting at different places. That's all there is to it. After you get that down, after that makes sense to you, you've made sense of that, right? Now his code will make sense to you. If I can find his code, because I can't use computers. There we go. Return has palindrome, I24. Skip the first 2 characters, look at the next 4. Has palindrome, this is for the next integer, right? Skip the first character, check the next 5. And then we check again. We skip we look at the next mile, right? Because this I represents the mile. We skip the first character, and we look at the next 4. And then we check it one more time for all 6. So what we're doing is we're going over how many? Here's his number. This is what he's doing. While I is less than 999,996. Here's the important thing. We're checking a ton of miles. We're doing a lot of computation, right? But it's not a lot for a computer, and it's way easier than actually learning math. So what we do is we simply take this big, long range of numbers, and we brute force it. That's actually what we call it, right? So if you're in security, brute forcing is creating something dumb, right, that does what you need, but it does it in just a fashion that essentially doesn't matter. It's guessing until it guesses it right. So that's what we're doing. We've created something that guesses a million numbers, right, or whatever, almost a million numbers, 4 shy, and to try to find out what satisfies this guy's riddle. And that to me sounds a lot easier than doing it on pen and paper with math, but who knows? Okay, Ed.
Usually, if you can come up with a routine that's a little bit better than brute forcing, you can save lots of time and electricity.
You can. That's true.
That's true.
Brute forcing is not going to get you a Nobel Prize, but it'll get you the job done on a riddle, before your lunch break is over. So, I mean,
how many digits that number is.
Yeah. This we would say it runs in linear time, right? So he's checking a million digits, so you have to get through a list of a million things, essentially. You have to process a million different iterations of this loop. If you had, let's say, an odometer that was 100 billion digits long, this probably wouldn't be a good idea. You probably want to involve some math and some PhDs or something like that. But for us, it's plenty fine, and that's why it's a good example, because we can make sense of it very easy. It's this riddle. We all understand what he's talking about, and we solved it with Python, right? Okay. So good example. Car Talk 3. Do it on your own. If you have any questions, ask in Discord. Which, by the way, GitHub. Bada boom. For those that want to do his code, it was suggested that I be a little bit more active in the Discord channel in class, and I think that's a great suggestion. Bada boom. The link to the Discord takes you to GitHub. If you've never seen GitHub, we're not going to be going over it today, except insofar as to say that the download link is right here. It's the green button. You can click the download link, you can get it, and you can see all of his code. So you click download and then download zip, and you get all of this stuff, the code, the text, everything. Everything you can see that you can navigate here. And that's a great method of doing it and playing with it. Then all you do is literally go into the directory. I hope you know enough to get into it. If not, pull it all into PyCharm. And pulling it into PyCharm is not difficult. I can show you how to do that if you care, or if that helps. But I just run it right here. And again, let's run this because we didn't yet run it. This is Car Talk 3. And no, Car Talk 2. I just ruined the third one for you. Now you don't have to do it. There we go. The following are all possible odometer readings: 198888 or 199999. So he's almost at 200,000 miles either way. That solves this riddle.
Sorry, which one's the answer?
There's two possible answers.
Oh, one.
And those are the ones that satisfy the riddle. Does anyone have any questions on this example? Okay, do we all feel kind of comfortable with it? Because this is more or less a real world problem, right? We're throwing computational power at a problem with minimal Python skills to get the job done and give us an answer back, right? Insert capitalist and paycheck, and you guys are all done. It's ready to rock, right? Okay. So we start off with the next chapter with list. Okay, we talked about strings, and we talked about this. Let's go back to the first one. This is the easiest one to do. True or false is a what?
Boolean.
Boolean. What is a Boolean?
The value that results from 1 or 0, the true or false.
Yes, but when we in this context, it's a type, right? It's the simplest type because it can only have two values, true or false. Right? That's a Boolean. All of this logic you have is true or false. So what it boils down to. You're either doing something or not. Okay. Here's the cool thing. We have introduced Booleans. We've introduced numbers. You guys know that. You know strings. We've even shown how to iterate over strings into characters. You guys have pulled in all of this knowledge about numbers, about strings, about Booleans, right? But that doesn't give you enough to model a program yet, right? And you're missing huge chunks. So now there's 3 different data types Python has that are kind of like the ones that bring together your whole program. And these are the ones that you'll see everywhere. And these are lists, tuples, and dictionaries, right? And when we say Python is a high-level language, one of the reasons we say it's a high-level language is because you don't have to manage basic resources to get this type of functionality. If you have more than one of something, it's a list, right? That's just how Python manages it. So if I have lots of numbers, I have a list of numbers. If I have lots of characters, I have a list of characters. Python has a special thing for a list of characters. They call it a string. But the reason why the string works with the indexing stuff is because Python makes it a list. And when it doesn't make it a list, you can transfer to and from very easily. So you see that. So when you start to model a problem, let me give you a case in point. I want to make a computer program, and I want to represent all of the people in this classroom. Right? How do I do that? We have a list of people. If I want to find out how many people are in the classroom, I take a count on that list, right? Just like I would count characters. This is how the reason why the Python makes the interface for strings and for lists the same is because these are so generic. You want to do the same things with them, right? So a list is a sequence, right? More than one thing. We have 10, 20, 30, 40. We can have a list of strings, a list of numbers, more than one thing of either. We can even have lists that are of different types. This is a Python thing, right? Well, other languages do it too, but this is the point here is that in Python, lists are not strongly typed. You can throw whatever you want to in a list. The only thing you know of in a list is that you have 0 or more items. That's it. It's a container. List is a container with 0 or more items. Now, in a string, all of the elements are characters, right? But it's not necessarily so in other forms of lists. Lists outside of a string, you can put anything in. So here we put a string, spam. We put the number 2.0, which is a float. It has a decimal part, right? We talked about that. We have the number 5, which is not a float. It's an integer. And we have another list inside. So lists can have lists themselves, right? And they can have 0 or more lists. It doesn't matter, you can keep going. A list within another list is nested, and that's a keyword there. You're going to want to, not a keyword for the language, but it's a word you're going to want to learn. A list that contains no elements is called an empty list. You can create one with empty brackets. So here this shows you how to create an empty list, and here we're creating a list of cheeses, a list of numbers, and the empty list. And then we can print them all out. We just hand them all to print, and it shows us. Okay, so you'll notice here one thing that should come away. How many people here have used JSON? Okay, if you use JSON, the brackets represent what? They represent lists or arrays, right? JSON arrays. They represent an array in JavaScript. And Python represents them the same way. So generally, when you learn more languages, brackets represent you're creating a list. or an array, whatever they call it. And when you put the brackets outside of the array, you're pulling an element out of that list, right? You're indexing into it. Okay. So here's how it looks. Cheese has 3 elements. 0 is cheddar, 1 is Edam, 2 is Gouda. And the key here is that when you iterate with the indexes, you're getting 0, 1, and 2. You're saying, give me the 0 element of cheese. Give me the first element of cheese, the second element of cheese, right? Using those indexes. If you do in, you get this, cheddar, Edam, Gouda. That's the difference between those 2 forms of iteration. In, you get the values, right? When you do the indexing form, you get the key into the list. And you look up with the key to get the value. Okay, so numbers, we have 0, which is 42, and we have 1, which we can change, right? And I don't know where he's going with this, but I'll show it to you in this. Let's see now.
It's under the diagram. Yeah, right there.
Beautiful. Okay, so here's what he's doing here. He's saying numbers 1 equals 5. So he set number originally to be 123, and he's showing you when you change number 1 to be equal to 5, what it does is it creates a new variable and it changes where the 1 is going. Right? So let me show you what he's talking about here. This is not too difficult here. If we say A equals 1, 2, 3, I can say A equals 1, 2, 3. I can say A0 equals 1. I can say A1 equals 2. You can see what it's doing. Now what if I say A1 equals 5? And now I look at A. What am I going to get? Anyone want to try it?
153.
153. Right? So he's showing you with that previous example that when he changes the direction of it, when he resets 1, he's getting a new variable 5, and that's where 1 is going. Right? And he's showing you down here where he does it. Numbers 1 equals 5. And this is because he introduces a new word, mutability. Mutability means they can change. Lists in Python are always mutable. Okay. Any integer expression can be used as an index. If you try to read or write an element that does not yet exist, you get an index error. If an index has a negative value, it counts backwards from the end of the list. Right? The in operator also works on lists. Cheeses equals cheddar, whatever. So then this is where we're seeing in. This is where they introduce in the context of iterating over lists. This is the check. So when we say here edam in cheese, because that's not a variable in a for loop, it's testing to see if edam is anywhere in cheese. Right? Brie in cheese, it's testing to see whether brie is anywhere in cheeses. This is the same thing as if I said, for cheese in cheese, return true if cheese equals brie. Does that make sense to everyone? Or do they want to see it? Do we get that kind of in loop thing? We talked about that a little bit. We have in inside of a for loop, and then we have in to test something. And if you test something, in is iterating internally. So if you say edam in cheeses, it looks at every element in cheeses and sees whether or not one of them equals edam. Right? If you say for cheese in cheeses, it's going to create a loop that gives you the ability to test cheese for every element in cheeses. Okay, traversing a list. Traversing is a really complex method of simply saying going through. Right? You want to go through all of the elements in the list, you want to traverse the list. So here we have for cheese and cheeses. This is the in loop method. Print cheese. Right? Here's another method you can do it. We saw this one too previously. We saw it in the strings chapter where we did characters. For I in range, length of numbers. Right? Numbers I equals numbers I times 2. That's actually a mistake. That should actually be, in my opinion, numbers minus 1. Does anyone know why it's not? Or is it, oh, here. The range returns a list of indices from 0 to n minus 1, where n is the length of the list. each time through the loop, range return. Oh, because he's calling it in range. That's the thing. Okay, so that's another trick, right? Let's go through that one really quick too. So if we say something here, right, like length. Let's say that I have a list. We say foo equals 1, 2, 3. What we previously did is we said length of foo, and we get 3 because we have 3 elements in the list. But if we say range of foo, length of foo, right, we get ranges of 0 to 3. Right, now here's the thing about range. The way range works, it doesn't count the last element. So if I say for I in range, print I get 0, 1, 2. And I'm showing you this because the book is expecting you to know it. But I don't think he's introduced it formally at all. Okay, so let's take a look at that one more time. In the previous examples, when we iterated over the list, right, we were doing length of the numbers minus 1. Right, we would say for I equals 0, or rather, we would say when we iterated through the list, we were iterating with numbers, 0 to whatever. Now what we're doing is we're using this range thing. And the range thing, when you give it the length, it's going to look at 0 until the n minus 1 element. You know, he says it like this. The loop traverses the list, it updates each element. Length returns the number of elements in the list. Range returns the indices from 0 to n minus 1, where n is the length of the list. I want to go back and I want to take a look at the tuple, the string thing, so we can see that and see how we used to do it. This is how we did it before. Okay, so here's your compare and contrast, so we can see it. Before we said I equals 0, right? And then we said while I is less than the length of the word minus 1. Because we did it this way, length of word minus 1 is going to take us to the last element. That's one way to do it. But rather than setting I equals 1 at the top and length of while I is less than word minus 1, we could also just say this, right? You could go while I in range of the length. This is essentially another way of writing this, right? So range is going to return all of the elements from 0 until the last that would be provided by that index. So we didn't see range before. We started off with I equals 0, and we went to the last element by doing length minus 1. Now we wrap the whole thing up in range. Okay, so that's your new piece now. For I in range, length of numbers, and then what we say here is numbers I equals numbers I times 2. We're essentially doubling every different element in numbers. So if I say here, numbers equals 1, 2, 3, and then I come back here and I say this is why I hate this Repple. 2, 4, 6. I started off with 1, 2, 3, right here. And then what I did is, we looped over it. We said for I in range, length of numbers, numbers I equals numbers I times 2. And that's going to double every element in the list. We're iterating through every element and doubling them all. Right? Now, here's another way I want to show you how to do it, right? I could also do it like this. I could say or x equals 0. This is the way we would have done it before. And then I can say while less than length of numbers minus 1, numbers x equals numbers x times 2. And I forgot to change x.
Thank you.
Thank you, Python. So the first time I actually created an infinite loop, and I can't even show that. Let's take a look at one more time here. Let's actually jump down here into.
To me, Evan.
Yeah. Okay. The moral of this lesson is, when you say that the REPL is bad for things, you should take your own advice. Okay. New Scratch file, Python. That's how you're supposed to do it, right? Now we're going to say A equals 1, 2, 3. Okay. We're going to use his ability here to duplicate this, right? We're going to indent it because Python. And then what we're going to do is we're going to say we're going to say x equals 0. While x is less than length of numbers minus 1. Okay, there we go.
Numbers. Different variable names.
Oh. There we go. Good catch. And let me delete the semicolon before someone sees that. Okay. Now we want to run.
With the print numbers. Both times.
Okay. Run. Scratch 1. There we go. Okay. 2, 4, 6, 2, 4, 4. Oh, this is because I'm using I. That's the reason there. That's easy enough. Okay. Okay. 2, 4, 6, 4, 8, 6. 4, 8, 6. What the?
Because you know, the numbers one's already, the list has changed to 2, 4, 6, so just multiply 2, 4, 6.
Yeah, so why did 2, 4, 12?
Oh,
You're short. You're off by one then.
You don't.
This, it was at 175, so that would go to
Wow, okay, okay. So this is what we had.
on higher. Plus.
That's not making sense to me either. Okay, I might have had a brain fart or something. What I want to look at here is, why did this code work up here when we did it?
It's correct. Length is 3, so 0, 1, 2. 2 is less than 3.
Ah. So why do we subtract 1 up here then, huh?
It started at I.
Because you're looking at the next letter.
That's
Yeah,
the reason.
'cause it's
That's
Json.
the, okay. Okay, yes. So here, that's exactly right. Okay. Good catch. So what we're doing here is we're iterating over this 2 different ways. And I wanted to show you both of the ways back to back, because this first way is just not getting introduced, and it's not getting introduced with much, much attention or explanation. This is the way we're doing things now. We're saying range, and then we're providing it the length of numbers. This is the way we did it before. Right? These are essentially the same ways of doing the same thing. Range is going to return to you a list of all of the indexes that you're providing it as an argument. So if you provide range with something that has 4 elements, you're going to get all of the possible indexes for that thing that you're providing it. Whereas before, we're calling length, and we're iterating itself until we achieve that length. So this is the way that he's doing it now. This is the way that we did it before, but they both accomplish the same thing. If I say A equals foo, bar, baz, and then 5, 6, 7, and then I say range A, range length A, you get 0 to 6, right? That's 0, 1, 2, 3, 4, 5, and then it stops, because the range iterates on to up until n minus 1. And then this is where we're at. Okay. I tried to explain it. Anyone have any questions on this? range iterates from the beginning of the list until the index n-1. You can create a while loop that does the same thing. You start off with 0. You keep iterating until the end. In the while loop version, the only difference is that you have less than length of numbers. In the for version, you simply say for I in. So in one, you're using in on all of the indexes, which are returned by range. And in the other one, you're creating this manually. Okay, so that's traversing through the list, right? Then we use those indexes into the list. Lists you can do some basic things with lists. They come with that ability. So one of them is adding them together. If you take two lists and you add them together, you essentially append one list to the other, right? The asterisk operator repeats the list. So we went through this in the first class. We said that if you provide an asterisk to numbers, you multiply. But if you provide an asterisk to lists or strings, you get multiple copies. It's repeat, remember? So we introduce asterisk can be multiply or it can be repeat, depending on what the operators, the things on both sides of it are. And here we're seeing that again. If you provided an empty list with 0, a list with 0, and you say times 4, you get 4 zeros. But if you say 0 times 4, you get 0, because then it's multiplication. So in list context, the asterisk is repeat. List slices, we've seen this before, because this is also the way strings behave. You have the starting point on the list and the ending point. T13, 0th element, first element, you want to go till the 3rd. Second element, 3rd. But you don't ever go till the last one, just like range. You go to n-1. So that's where we're doing this. So B and C. So 1 to 3 it's exclusive of the 3rd, right? 0, 1, 2, and we don't include 3, but we stop. If you omit the first index, the slice starts at the beginning. So if you do this T and you give it a single colon, you actually make a copy. You slice with all of the elements. But you can also give it something like 1, like we did previously. Remember when we did the recursive example with the ABC thing? And we said we're recursing until we get to a character length of 1, right? Each time we did it, we were recursing from the second character. So we would process it. We'd say the first character passes. Now let me look at the second character. Then we would process that. And we would say, now let me look at the second character. And each time we recursed, we would give the function 1 fewer characters. And we did that by specifying the starting point and not the ending point. So the slice operator takes 3 pieces, a start, an end, and a step. And we've now seen them all. We've seen a start without an end, which means you want to start at a specific position and keep going until the end, right? We've seen end, too, which means you want to start at the beginning and go up until this character, but not include it. And we've seen the step of -1. We saw the step of -1 when we wanted to reverse the string, right? So we have now the ability to take, we can say A equals 1, 2, 3, and we know what all possible values are for X, Y, Z, what they all mean, right? We know what all possible things that could be put to this are. Start, up until, but not including the end, because it's exclusive, and the step. Okay. And now what we want to do is we're going to look at some of the methods. So we went through this in the beginning of the class. I started off the class today, and I was showing that we don't have to memorize all of the methods for things, right? What did I show that we could do if we forget? Help. Right? So let's say we create a list, and we say here A equals 1, 2, 3, and I forget, and I want to know what I can do to A. I can say help A, right? And there it tells you right there. A is part of a class of lists, right? And then it shows you everything that you can do with the list. Extend, count, insert, pop, remove, reverse, so on and so forth. Now, the author is going to show you some of the examples he thinks are important. Append, right? If I call T, if I say T equals a list of A, B, and C, and I say append D, right? Well, the important thing to note here is that T changes. It's been mutated. T now has a D element at the end. So we've pushed the D onto that list. It's now at the end of it. Extend takes a list as an argument and appends all of the elements. Right? So you can append one element or you can append a whole list of elements. And that's where we use extend. So when we take this and we say t equals ABC, t2 equals DE, now you want to have ABC, DE, right? You can extend one list with another list. So you can append one element to a list, it mutates the list and adds the element. You can extend one list with another list, it mutates the list with a whole additional list. Okay, sort arranges the elements on the list from low to high. This is really useful. If you have a list and you have all of this stuff in it and you want to sort them, you can just call sort on the list. And it mutates the list, sorting it. Okay, map, filter, and reduce. He creates this thing here called add all. Takes a list, and it starts off with total equals 0. And now it goes through every element in the list, and it says total plus equals that element. That's how he's creating a sum, and it returns total. Right? So if I say, let's take it, and let's go to our PyCharm, and let's new scratch file, Python. Okay.
For X in total. For X. Okay,
Where?
For X and T. There's no T.
The T is right here.
Okay, never mind.
It just needs to be print, yeah. Okay. So what we're doing here is we're essentially creating a sum method, right? That's what he's doing in the book. So we give it 1, 2, and 3. 1 plus 2 is 3, plus 3 is 6. Print add all A, and we get 6. We're iterating over every element of the array, and we're returning one thing that represents all of those elements. That's the sum. So what he shows now is the important thing is that there's already a function called it. There's a built-in called sum. And we said before, if we want to know what all the built-ins are, we can just say help. And, oh. It's actually, so here's the catch. Python is not exactly consistent about these things, right? In my opinion, anyway. This is one of my critiques of Python. This is one of the critiques that other languages have since changed. There are a couple of functions in Python that aren't methods on objects. So generally speaking, the process of thinking that I have, when you want to know what you can do with the list, you type in help and you provide the list. And it tells you all the different methods you can call on the list. There are 2 exceptions to that. 3 exceptions to that, right? Delete. Delete is not a method on the list in Python. Delete is a function, right? It's an operator. The same thing with sum, and the same thing with length. If you remember, every time we've wanted to find the length of the list, we provide the list to length. We don't call the list dot length. Just keep that in the back of your mind. There are a couple of exceptions. Sum is one of them. So if you want to find the sum of a list, you would say sum A, like that. You wouldn't say a.sum, right? And I know that that sucks, but yeah, you just got to memorize them. So then there's other ones, capitalize all, and he does the same thing. He starts off with an empty list, and then he iterates for every character in the list you provide. He says append, adding, right? So we've learned 2 different things. We've learned append, which adds one element to the list, and we've learned extend, which adds a whole list of elements to the list. You call res.append, s.capitalize, right? So here's the question, s.capitalize, that is a method on what? A string, exactly. So here's the thing, if I say foo.capitalize, I get foo. Capitalize is the first letter. And that's exactly what he's doing here. He's appending the capitalized character, right? So to create capitalize all, he iterates over every different character and calls capitalize. And the reason for that is because the string.capitalize only capitalizes the first character. So if you want to capitalize all of them, you have to iterate through all of the characters and recreate a new string.
Or you can say upper.
Or you can what?
Upper.
Yes. Yeah. And I think he may get into that in a second. So yeah, only upper, and then he's going to introduce upper, right? As an operation like only upper is called filter. No. I don't actually think he mentions upper in here, but yes, I think if you say foo.upper, it uppercases all of the characters. So what the point here is that there is something that will uppercase all of them. You don't have to write your own. Okay. Let's select all the other ones sublist. Skip that. We're going to do deleting. Okay, deleting is the other option here too, where we talk about things that are not methods on the list. You see down here where you see del T1? This is how you delete an item from a list. So we said lists are mutable, right? Mutable means you can add elements to a list. You can change elements in a list. We saw that, where we changed the index of 1. We saw the little graph and it scratched out the old value and it moved the arrow to the new value. Well, the other option you can do is delete elements in a list. And to delete the element in the list, you provide the index. So if I say here, A, I have 1, 2, 3. If I want to remove the middle of that, I can say del A1. And now A is just 1 and 3. Right? So del is another option that you have. So you can delete elements from any point in the list with the index, or you can delete elements from the last element of the list with pop, right? And he shows you that here. I don't think that's all that important because in Python it just calls delete internally, so it doesn't. It's all popping is you see that in a bunch of other languages, right? So when you have a list, we went through this concept of a stack earlier. You can push things onto stack. Well, the opposite of pushing things onto the stack is popping them off the stack, right? So if you want to remove the last element of the list, Python creates an easy way for you to do it called pop, right? Okay, if you remove more than one element, you can use del with the slice index. So this is the Pythonic way because you get this ability to remove more than one element or elements with steps and all of that kind of stuff. So if I say here A equals, let's do
2 SSDs. 1 terabyte.
Let's say that you want to remove every other element from this. You could go del, and you could say blank blank 2, right? Oh, del A. There we go. And now we've removed every other element. We removed 1, we removed 3, and we removed 5. They're gone. You've mutated that list. Okay. So this is the crossover. Strings behave, generally speaking, like lists, but you can transfer to and from using this list syntax. So you can call the constructor list and provide it a string, and then now look what you get. You actually get an explicit list where every different character in that string is an element. It's not all that useful. It is useful on a couple of occasions, but generally speaking, it's not all that useful because that's how strings behave anyway, right? So here's the thing, if you split a string, it splits it on white space. This is useful because we talked about processing strings. One of the things you may want to do is look at every different word in a string. The default for split is the split on a white space. So that's what he's showing here. If you say, the string foo space bar space baz becomes foo bar baz. And likewise, you can provide it an argument. So like, let's say that you have a CSV of some sort. You could do something like this. Oh, no, I'm trying to pop that in there. There we go. Right? Mm-hmm. So you can split on an explicit character, but the default is white space. Does that make sense?
Yeah. Evan, if you're having to process text like this, is Python particularly suited for that, or you'd rather use other languages for that? Like, because you're parsing, you're slicing and dicing, you're,
I think
know.
that really, it's not a question of efficiency. That's what you're bringing. You're trying.
I'm not worried about how fast it is. It's more of like, I think there's a lot of overlap between this and say JavaScript, where you, in terms of parsing and splitting
There
or
certainly is.
building an array or deconstructing an array or.
There's a lot of overlap. Yeah. These are both, Robert?
I would say it's to directly answer your question, it's kind of a toss-up between just, gluing stuff together with a shell script, like with cuts and greps, or actually going with Python. Like if you're just doing a rapid prototype.
So, just to add a little bit to it, a lot of times when you're manipulating text to either clean it up and get it ready for some sort of processing, or you're manipulating text in order to, get it in some sort of format for storage.
Right.
And so, whatever you're trying to get the text ready for processing, whatever language that is that you're about to process the text in, a lot of times it's a good idea to manipulate the text in that same language. A lot of these functions look similar across languages because they're incredibly useful.
Right.
And so they wind up getting re-implemented in languages that don't have them. So people won't sit here and go, gosh, I just really wish I had something to split this string on a character. And so the idea is that the ideas get recycled between the languages.
I would say this, to one step further. Python as a language is not especially suited to do anything better than any other language, right? It is in many senses just like JavaScript. I think it's really silly to get into a comparing mechanism for it, which one's better suited. But I would say this, all of these languages, when you get into when you learn the basics and you're doing this kind of stuff, you're going to use a library. You're not going to be using split, right? So when you get into the world of libraries, Python is a great language. JavaScript has great libraries. That really, to me, is where your professional code is. What I'm trying to say is changing languages to do this kind of stuff is silly. Use a library to do it, and it'll work great in any language. Okay. That's how you would take your game up a notch before you switch languages entirely.
Yeah.
Okay. Ed, you want to say anything else to that?
No, I mean, knowing the primitives, sometimes you can save a lot of effort if you just know the one or two pieces that the library would have wrapped for you. It really depends. And it really depends on what you're doing with the text. Like if you're trying to break the text apart to do some sort of validation of syntax, then absolutely you want to use like a parsing library and tie it into parsing rules. But like if you just want to grab the second column like you might with awk, then sometimes all that stuff is overkill.
Yep. All right. So here we have spam dash spam dash spam, and we set the delimiter and we call split with an explicit delimiter, right? So this is, I guess, if you wanted to create your own parsing library, like I said, great for learning Python, but when you do this professionally, you're going to use libraries. Pinning for the fjords, whatever. Delimiter equals the empty string, or the string with the space, not the empty string. And what he's doing here is he's saying join. So this is something different. We saw split. Split's going to take that string with spaces. It's going to give you a list where each different element in that list is a word, right? Foo space bar space baz dot split is going to give you a list with foo bar baz. What if you want to go back to a string? Join. Join is the opposite of it. So you can provide all of those different elements inside of the list with something to join them on, and it does the opposite. So look, we just did this, foo bar baz, and we split on the comma, and we got a list with foo bar baz. What if I want to go back, right? Join, comma. Okay. Where did I miss? Oh, delimiter.join. Okay, that's really sad. Yeah. Okay. So new string, or rather, new list equals this. Now I have new list, and I have foo bar baz. Now I can say comma dot join new list. Foo bar baz. You see that? So I want to show you this here. We start off and we take it from this, which is the string, foo, comma, bar, comma, baz. We say split on a comma, right? What do we end up getting? We end up getting this, foo, bar, baz. That's a list with 3 words. Now if I want to go back and I want to get the string, right, I give it the comma and I call join. So string.join takes a list and it joins the list with the string. Okay. I'm keeping Adrian on his feet today.
I'm not sure why you needed the delimiter there.
You have to specify what you're joining by.
Yeah.
Okay.
And so that delimiter is basically the item that's going to be put in between the elements of your list. Evan, probably a better example would be like having a telephone number, pulling out the minuses, and then joining it on quote, quote. So you could stuff it in a database.
Okay, yeah, we can do that. So here, like, look, if I said here, number equals, we'll do my number, because what's better than giving it to the whole internet?
Well, I know.
There's my number right there, right?
Just do a fake number.
Okay.
Don't do your
That's
number.
not your number.
That's not your number.
Sure. Okay.
Find out.
So that's my phone number, internet.
HostGator's number.
And now let's say that you want to take out the dashes in it, right? What we're going to do here is we're going to say number.split on the dash.
Yeah.
And now what am I going to get? I'm going to get all 3 little components of it. So I can say segments equals number.split. Now I have all of them in a list. Now if I want to make it into a number,
You get it.
I could say like this, dot join
Delimiter.
segments. Well, what do you want the delimiter to be? If you don't want a delimiter, you can use an empty string, right? And I get this. Now the only thing left is to make it a number, right? So this should say here, string number. Now I can say int string number. Okay, so watch. I'm just keeping on your head. I almost feel bad. Okay, 281 split. 281 901 0011. Right? Lots of zeros and lots of ones. I keep it simple.
Minus signs.
Yeah, there we go. And now I'm splitting on the dash, right? So now I get 281 901 0011. 3 different elements in a list that represent each one of those segments of the phone number. Now you can say here, what you want to do is you want to join on an empty string, right, that list. Now I have a string, 28190100011, right? Now if you want to keep your phone number as a string of integers, you can. But you would call int on it normally, and then you actually get an integer. So this would represent my phone number as an integer. So if you have a little HTML form and you ask people for the phone number, they want to put dashes in there because that's how people used to read the numbers when they were talking to their grandma over the telephone. But now what you almost always want to do when you're using phone numbers is store them in a database. And it doesn't much matter how you would read them to grandma. So you typically remove the dashes. And different people in different parts of the world put them in different places and it's really screwed up and there's a whole library for this. Yes?
That doesn't actually
You go to-
work
you can
because
go to
of leading
Carroll for that.
zeros.
That doesn't actually work as a what?
Like, because leading zeros are important to the phone number. And so you can't use sort of as an integer.
That's right. Yeah. If you have leading zeros in your phone number, which is only valid for a country code, right? Then it doesn't work.
And never valid as a number because
Like so there's a country code for those people that have been outside of the United States.
Well, it's an extension that flags that there's going to be a country code.
Right. So to dial inside of the United States, you dial 01, right? If you're in Europe and you want to call America, you 01, I think, or
01.
yeah.
Okay.
There you go. 011. There we go. 011. So the 011 is significant in that. And Robert was pointing out that if you say integer 011, whatever, then the 0 goes away, which is a valid point, but it's also not the point of the class. So again, we treat these examples very simply because this is showing you like how you can go through these different processes in your head, or with Python, very simply. If you're doing this for money, you're going to use a library, right? Even for phone numbers, there's literally lib phone number. Google produced it because people kept getting it wrong.
Keep in mind that like libraries are wonderful. You should always look for one initially, But sometimes you'll be solving something that there isn't a library for because basically you're doing it so differently than everybody else. No one's decided to build a library yet. Then you can build your own.
You're a long way from that point, guys. So if there's a library, grab it. But yeah, I see that.
You want to do yours.
Yeah. Generally speaking, I don't want anyone in here writing code for at least a year before they learn how, after learning how to write the language, then you contribute and you can improve on libraries. So what you have here is options and values. You say A equals banana. We run these B equals banana. We know that both A and B refer to a string, but we don't know whether or not they refer to the same string, right? In one case, they refer to two different objects that have the same value. In the second case, they refer to the same object. Okay, so this is introducing to you this concept of is, right? Is referring to object equivalence, right? So if you say A equals banana, B equals banana, and you want to know whether or not A and B are the same, you can say A is B. Okay, this is really stupid. I'm going to skip this because this is actually Python internals and it doesn't actually matter. Ignore that part. Okay, here's what he's talking about here. Aliasing. I'm wondering how much of this stuff I'm going to get done before I hand this off. Ed, what do you think about picking this up?
You've got like 8 more minutes,
yeah,
so I would say just don't even start the next big section.
I don't want to start the next small section.
Small section's okay, but like don't start dictionaries.
Yeah, definitely not going to do that. Okay, here's the deal. This is getting to the point that in Python, right? It does special. I'm going to explain to you what it's doing, and I'm going to tell you why I don't think it really matters. In Python, strings undergo a process called interning, right? He doesn't actually specify this as the name, but it's this process. And I even commented on this in the last class. Remember when they said, Python strings are immutable or whatever, and it amounts to the fact that internally they may be or they may not be. This goes to this process of how Python stores things internally, not what it makes visible to you. So there's this thing called is you can use to determine whether two things are the same to Python internally, right? A is B. You create a variable called A and you store in it banana. You create a variable called B and you store in it banana. And then you call A is B. Do both A and B refer to the same thing internally? Right? The answer is they do. They do because Python internalizes banana. And it sees that you're setting two variables to be the same string. So Python internally has one copy.
So if we reassign B to Peach or something, then it would have to obviously store, then it realizes that then it has a new iteration in it. I think I understand what you're saying is that if there's only one reference,
it does what you want. It doesn't, so yes, A equals ASDF, B equals ASDF, right? A is B, true. B equals foo. A, ASDF, does precisely that.
Yeah.
It realizes that the version that you're modifying is not the same as the other version, and you simply get a different copy. Now if you say A is B, false. They're not the same. They're no longer pointing to the same object. I have no idea why that's in this book, but that's what he's talking about there. So for the purposes of making sure you understand it, that's what it is. A equals 1, 2, 3, B equals A, B is A, right? True. The reason why this works and why B and A are referring to the same copy is because you're setting B equal to A. That is important. That is something you're going to want to know in Python. When you copy an object into another variable, right, you're not copying the underlying object. You're simply making the new variable referencing.
And whenever you change it, Python figures it out and assigns it to a new memory location or object of memory?
If the object is mutable, you simply have changed it for both of them, right? But in the cases of strings, those objects are not mutable to you. You can't see that. So it just changes, you have two different copies in memory.
I was going to say perhaps a quick Python example of just like deleting an element from the original. just like that same code, but followed by delete, a.
Yes, okay, I see what you're saying. That's a good idea. Okay, thanks. So here's what we're going to do. We're going to show you this here. If we say A equals 1, 2, 3, B equals A. Now here's the thing. If I say delete A, and then I say 0, right? Now we all know that A is going to show 2, 3. I hope we're all on board with that, right? What is B going to show?
1, 2, 3.
Okay, here's the thing. A is literally the same thing as B. And this is a mutable object. Lists are mutable. That means when you delete one, you delete the other. B is going to show 2 and 3 too. I think that's right. That makes this book, I don't know if the author teaches with this or not, but yes. That's what the author's trying to show you right here, right? He's trying to show you that some things are mutable, and when you mutate them, it mutates them for all things that point to it. They all show those mutations. Some things are not mutable, and when you mutate them, you get a different copy, right? So it depends on whether or not Python categorizes these things as mutable. Okay, and that's all there is to it. So he shows here, this is the whole binding thing, right? And he goes here to say strings are immutable. So when you redefine a string, right, you set a variable equal to a different string, it doesn't change what any other variable equals to, right? Guys, that's it. I'm going to leave it off with list arguments. We're going to take it from there. We did almost 30 pages or something like that. 20 pages? Been a lot. So yeah, take care, have fun, and if anyone has any questions, drop